screen is visible?
Yes, you just go to slide mode.
Yes. Okay. Voice and screen is visible. No?
Yes, yes, very much.
Yes. Okay.
Okay, good.
One sec. Yes. Uh, Good evening, all. I'm Prasad Nazare, working as a quality engineer with Cast Iron SGN Foundry at Anita Instrument, Kolhapur. Today, here at a DFG, I would like to share my experience on a daily foundry management. Before that, I would like to express my sincere gratitude towards few people. First one is a person who gives me an opportunity to work with the foundry fraternity, Honorable Dr. Mrs. M. Pillai Ma'am, Director of Anita Instrument, Kolhapur. The second one is a person who pours a knowledge and generate views in me, Honorable Mr. Avinash Doshi sir, the well-known foundry consultant at Kolhapur. Third one is a person who has provided a practical approach and a platform to me, Honorable Mr. Sandeep Kulkarni sir, whose remarkable work has opened up doors to all foundry fraternity through the work of the DFG. So, to run the foundry, one of the main target is to generate the profit. And to generate the profit, now it's time need to run all the wheels coordinately. There are different types of a department saturated in a foundry like production, quality assurance, systems, support function, etc. etc. But to get efficient and effective production is a timely need of today's market. So we have to assure that we running with a quality assurance department, system and support function togetherly. A wise man said that a system should work, not a man. So we must think on how our day-to-day activity can be systemized. There is a tremendous role of a support function. Though all points look different, we have to coordinate these all points because our motto is clear to generate the profit through the efficient and effective production. So to uplift our foundry activities on day-to-day basis, we have to coordinate these all. So today I would like to emphasize on this topic that to run the production to uplift the foundry floor, how we can coordinate these all functions togetherly. A daily foundry management, if I ask that what is a daily foundry management, it is equal to the disaster management. You go to the foundry and every time disasters are waiting for you. To manage all these, according to my opinion, one need a 50% of a subject knowledge, 25% of a people management, and 25% of a common sense, which cannot be taught at all. It is a part of parcel of everyone's life. So we can only talk only about subject knowledge and people management. Let's start with the subject matter expertise. To know your plant, it is like to drive a car, you must know the basics of a car. So to drive a plant or to run a plant effectively, we must know our plant. अगर फ्लोर मैनेज करना है तो उसे पहले समझना ही पड़ेगा. Every plant has their own SWOT analysis. They have their own strength, weakness, opportunity, and threats. For example, for my plant, the strength is I have experienced team, well conditioned and maintained sand plant, optimum pouring line. Likewise, my opportunities are to make mistake proofing through the automation implementation. So it is a customized activity for every plant. But amongst all, the one of the keyword is safety first. One must know all equipments and their operating panels, their emergency switches, and the exit, or we can say a contingency plan. Next is equipment capability. Floor manager must know the equipment capability of a plant, or we can say what plant can do for us and what it can't do for us. Say a molding machine, for example, ARPA 450. We all know ARPA 450 machine can have a maximum capacity of 450 kgs. Among these 450 kgs, we have to accommodate weight of a match plate, weight of a pattern cavity, weight of a mold box, and weight of a sand. Togetherly, these should not exceed the 450 kgs. If we deteriorate these 450 kgs with match plate, pattern cavity, mold box, and a sand, we could not get a good mold. So we could not ask or blame to the production person for the mold dilation due to the poor hardness. Next is a furnace. We must know the pharma dimension, coil level for a sand cooler capacity in a temperature and in a weight terminology. How temp how much temperature drop it provides and how much sand it provides per hour. Bentonite is activated actually in a sand hopper. So storage hopper capacity has key role in a production planning, and likewise it correlates. Like that prepared sand hopper capacity. For example, we produced 30 numbers of mold in an hour. Say for example, our sand hopper which can produce a 50 mold sand in half an hour. So if initially we fill the hopper, the excess sand gets dried and simultaneously it gives defect like sand drop and sand erosion. But we could not evaluate how this defect can happen on that day only. So likewise, equipment capabilities and our day-to-day management is correlating. According to which, pouring line distance is proportional to the travel time of a ladle. We must know the treatment time, inoculation practices. For the inoculation addition, what is the orifice size, what is the discharge of a inoculation. So one can note from pin bush of a mold box to the furnace or a sand plant. Togetherly, on a technical basis, these saturation of information is called as a design manual. In a technical terms, same thing is interpreted at a QMS as organization knowledge, which is written at IATF 16949, page 24, clause 7.1.6. You know what a plant can do. That is the basic thing. What a design manual can give us. It can give a guideline for development or acceptance of a new part. It help out to integrate the existing process. It help out to achieve better control on a process, as well as to set process inspection parameters and its inspection frequency. But do remember that each company has their own SWOT analysis, so own customized design manual. One cannot relate each other's design manual. Then the role of a support function. To work on a shop floor, we need man, material, machine, and method. Method is defined by technical people like us. But to achieve a good control, we must control on a man, material, and machine. A man is taken care by HR department. आप मानो या ना मानो, but the truth is their always target is always cost cutting. Next is a material, which is an aid of a store and purchase department. There is always eye of a management. And third one is a machine, which is an aid of a maintenance department. According to whatever my experience or whatever I have seen, it is a most ignored area in every foundry, but it has a maximum cost saving potential. For example, again we took example of a ARPA 450 machine. A standard manual or machine manufacturer says the standard operating pressure is a 6 bar. If machine at our plant is consuming 7.5 bar pressure due to its leakage issues. So what we are costing for? We are costing for wear out of a parts due to excess pressure, first of all. Then next is the excess cost of air that we are paying for. Then lack of air for other operations. So 1.5 bar pressure looking very much small, but it is costing us very much long. These all things are also related at a QMS systems as a total productive maintenance. Just we have to look after that. Next one is a rejection, the most sensible word in a foundry. On everyday basis, we have to carry this word and live with this word because it is part and parcel of our life. To handle this, most important thing is a data acquisition and data interpretation. How we collect the data and how we interpret the data. So right finding and right root cause of a defect is a 99% achievement of a solution. Monitoring of a rejection is another thing, but the monitoring of rejection on a production quantity or inspection quantity is a nowadays question mark, because most of the foundries I have seen that they are monitoring rejection on a production quantity, but the part which has not inspected, it is only at the inventory. How we can say that it is a right part or a wrong part? Another aspect is overall rejection and stage wise rejection. We have produced parts at a different, we have produced parts and parts at a different stages. So we could not correlate the part at a fettling stage with the part at a machining stage with the part at a customer stage. So I would like to show Excel sheet. Yes, here is a part name, number, part details. We have to take care for a foundry stage, the rejected quantity at a foundry stage and inspected quantity at a foundry stage. So rejection at a foundry stage is a different, then rejection and machining stage is different. Likewise, rejection at a customer stage is a different. So we could not correlate these three stages with each other. Okay. Then strategic approach for evaluation of a defected parts. How we do the evaluation of a defected part is a crucial thing in a foundry. For example, I have generated my own sheet. First, we identify the defect. Say it is a blowhole. Then, at what stage the defect has came out? It is at a machining stage. Then it comes with a severity, how much it contributes. Defected are 10 numbers, inspected quantity 100 numbers, so severity is 10%. Then we go for a traceability. When it happens on a same day, different hit at a shift number 1. Okay, then next is the location of a defect. Cope box on a flange, all parts have a same location. Then according to our experience, we found out probable causes for a blowhole defect. It can be done for due to sand moisture increase, metallurgical aspect, and venting. Based on a probable causes, we have to check reports. That is verification of a report. For sand moisture, we do check molding sand reports. For metallurgy, we check lab reports, and for a venting, it is our past experience, TGR and TGW. So when we come to know all of about two molding sand reports and lab reports found good enough, then the root cause is saturated as a central vent not opened. Likewise, evaluation should be done to have a strategic approach on defective part. Like a design manual, we can also make a defective manual. Based on this data, we can generate part-wise defect manual. Usually defect relates with the geometry of a part. Every part has a different geometry, but we can also check out that a periodic defect is happening with the same kind of a part. So it depends on plant capability, foundry practices, and a geometry. Likewise, a date, defect, defect severity, defect location, its root cause, and action taken. So in near future, if we get same type of a defect, we can also recall what action we had taken. Setup approval or a first piece inspection. Foundry person must know what to control at a what time. According to system, verification of a job setup is nothing but a setup approval. It is act of a detection, but can save a lot for us. I would like to show one of the setup approval. Okay, this is a production plant setup approval, which pattern is on a planning, what special intimations provided by the production in charge, and what comment or what happening is recorded by the supervisors. So it is just like a communication book. Then what he must check before the production. First one is a pattern identification and its inspection. It should be inspected and approved by the pattern shop with a green tag. Then sand hopper level, water tank level, pump working, dry mixing time, water addition, air pressure. Likewise, mold hardness, mold visual inspection, mold closing, melting details, ladle conditioning, ladle crane working, furnace lining, timer or buzzers working. Spectrometer should have a standard reading. Spectrospark with a black ring. Inoculation pot must be available and weight as per requirement of a part. Charging material availability. So if we first of all check all these parameters, then we have less hurdles at a production site. Setting up of operating limit and specification limit. There are two types of a limit. One is operation limit, which has a narrow width in which shop floor supposed to do work. And another is a specification limit, out of which part if fails, both limits decide through the validation. One must do a validation to decide both the limits. The crucial activity in our day-to-day foundry practice is a charge mixing. We have to add CRCA, RR, boring, scrap, and the alloys. But what are the recovery of alloys? What is the condition of a CRCA of a today's lot? Making so we have to set. I have here my Excel sheet. We have to set first of all a bath metal target and a final chemistry in terms of a percentage as well as a kgs. So if we put on the values, of a CRCA, RR, boring and scrap, we do get values of what amount of addition of alloys we require. It will be the easiest solution on a shop floor to work with. Inward charging material and alloys after conducting an actual test. Try to vary only single parameter and keep other as close tolerance and update sheet for a recovery. How a daily activity should be planned. If we take its 8 to 8.5 hours of a shift or a working hour of a foundryman, we can distribute in 5 segments. First 2 hours, he must evaluate yesterday's happening, evaluation of a respective departments. Then half an hour should be the CFT morning meeting for the production, consumption, issues, rejection and all that. Then next 2 hours should be consumed on a root cause analysis and finding. Another 2 hours for the preventive action. And one of the best thing of a planning is to plan in advance. Last 2 hours for the planning of tomorrow's tooling readiness and material availability. So we talk about the evaluation of a respective department based on yesterday's performance. What we must see. A day should be start with a fettling department. First is a short blasted bunch inspection. 5 to 10% of a yesterday's production bunch should be kept for inspection of a quality or a production manager. What he must see is the extra metal, sand erosion, riser working. Our riser has worked or not. If worked, then at how much percentage? Then the filter working for slag and sand contamination of a part, ingate or runner bar. If the sand contamination at a part ingate or somewhere at a runner bar. Then surface finish, then sand or core crushing. Next to see after bunch the casting. Casting weight inspection can resolve our day-to-day problems at all. Then the dimensional inspection based on a sampling, then surface finish, then fettling stage defects. Another area is a knockout. What to see at a knockout is a sand condition with respect to peel off and a casting damage. Third is a pouring. We have to see a pouring temperatures and a ladle condition. Then at a melting furnace condition, at a furnace, we have to see the lining condition, damage, slag saturation, and slag generation so that we can get how our raw material is. Then at a melting for a production, we have to evaluate yesterday's total melt, unit consumptions, yield, and material consumption. At a metallurgy aspects, we have to see a spectrometer reports if necessary. At a molding section, we have to check sand parameters, air pressure, mixer condition, hopper level condition, and cooler working condition. Likewise, a daily tooling inspection. Daily tooling inspection is a must activity. Once you ignore a tool, tool will not ignore you. So identification by tagging is the best method to communicate with a pattern shop, with production department and a quality department. Checked and ready for production pattern must be green tagged by the pattern shop. Used and for inspection tool must be identified with a yellow tag by the production department. Non-productionized or hold tools for quality issues must be red tagged by the quality department. On a day-to-day basis, pattern shop check the tooling for some of the checkpoints like crack, warpage, surface finish, identification, part name, vendor codes, vent condition, pin bush condition, damage or undercuts, clamping condition, gating system as per method card, matching phase free from dents. It is a simple form of a tooling inspection, or we can say a pattern history card. It should be start with the day one of a pattern manufacturing. We have to decide a pattern life. With the 80% of a pattern life, we have to order a new pattern. Suppose for a cast iron pattern, we have said 1 lakh of shots. Then new tooling order after 80,000 shot is must. We have to decide layout inspection frequency. Say for a 10,000 shots, after every 10,000 shots, we have to do a layout inspection. Likewise, we have to set a 3D scanning inspection frequency. For example, 40,000 shots, after 40,000 shots, we do a 3D scanning inspection. So monitoring these all activities along with a production can uplift our foundry. At a foundry, we do a sampling inspection. So one sample is a representative of all the activities related with that sample. So for a sampling inspection, there are some key guidelines like withdrawing right type of a sample, withdrawing right amount of a sample, then sample preparation for a testing, calibration of testing equipments, then validity of a lab solution. We have to take care of these all points so that the sample we are testing can give the actual results that happening at a shop floor. There are n number of a tests at a foundry, but we talk only on the spectro and hardness right now. A spectro die, this is a standard dimension of a die taken from some foundry standard. It says the material should be a copper, daily verification for damage and a cleanliness. The temperature of a die while pouring the coin must not increase the room temperature plus 20 degrees Celsius. If we want to apply two dyes at a working site, then we should apply, because a die is a representation of all alloys. If the sample is withdrawing not okay, what the spectrometer can do for us? Then another is a hardness test. It is ASTM E10 standard. Minimum specimen thickness with a diameter of indentation. So based on this, we can say that a 10 mm of a ball, 10 mm of a BHN testing ball could not give a BHN test or could not give a hardness for a specimen less than 1.5 mm of a specimen thickness. 5 mm of a ball could not give a result for a specimen thickness below 0.7 mm. There are some cool facts with hardness testing. Distance between two indentation and diameter of a indentation. So distance between two indentation must be greater than 3 times the dimension of the diameter of the indentation. Another is distance of a edge and center line of a indentation. So indentation center line and the edge of a part, that distance must be greater than 2.5 times the diameter of the indentation. If we are testing hardness on a curve, that radius must be greater than 2.5 times the ball diameter. After the subject matter knowledge, we come to the people management. Nobody wants to fail. Everybody wants the chance to speak, to attain, to learn, to implement, to make the change. People are bound to make mistakes, so build the system likewise. Every foundry must develop their own customized system. We found a communication gap we have to resolve for this. More you communicate with floor people, more facts get floated. On floor, we only inspect, supervise the things, but they actually do the job. Analyze the strength of people, give people chance to improve, to act, take them in a discussion in a CFTs, always keep them in a learning phase so that awareness increased. Let them know new facts. If they get ripen, you get the profit. So I would like to conclude that कोई भी foundry perfect नहीं होती. We have to make it perfect. Thank you.
Thank you, Prasad. Thank you very much. It was a nice presentation again. I think you are tried to uh, give some inputs for process control, quality, and related to production as well. And in real sense, I think you have given daily management, what exactly has to be done on day-to-day basis as a supervisor, as a middle management, that you have rightly approached this presentation. So thank you very much. Any questions? Please raise your hand, or you can put it in the chat box. Prasad, you can see the chat box as well. I'm looking at raise your hand. Any questions? Prasad, I have one question actually.
Yes, sir.
You have shown that basically this chart about the daily management aspect, or you can say the checkpoints before you start the production.
Yes.
Yeah. So this is from right from tooling to your sand plan, molding, melting, everything.
Yes. Setup approval.
Setup approval, correct. So are you thinking that it has to be done by the production person before he start his shift, or you are looking it as a auditing point?
No, I'm looking that a production person must follow these points
Okay.
because what I can audit is only monitoring of our process, how we are working with our system. Their motto is only that. But if we want the more control, we have to look at a certain points. So that I have said now, what to check and at what time to check, that must be known to the shop floor person.
Yes. So you are asking the production person to check all the points, and if there is any controversy or any loophole is there, he should correct it and then start the production, isn't it?
Yes, definitely.
So that whatever production is there, it will be a quality production.
Yes, definitely. It is a preventive approach,
It's a
rather.
preventive approach. Okay. There's one question in chat box: how to handle patterns. He is asking about lifting and etc. So Deepak, are you there? You can answer this question.
Hello. The
Yeah.
question is so how to handle the patterns or lifting the patterns. How to handle the pattern? For example, lifting etc. Handling of the pattern need to be very systematic. Of course, it is depending on the foundry to foundry, the size of the batch plate and everything. First, you develop the proper rack system depending upon the size of the batch plate. Then handling maybe through mining or crane. While applying the with mining, you can lift the pattern with the two arms. It should have a proper resting. Ensure that this pattern will not be get touched to your mining. Okay, this is the one method of handling the pattern. Sometimes for the high pressure molding lens, patterns are being kept vertical. So you have a very, if you go for very high kind of the mining, there is a facility of the tilting the mining with the 90-degree and keep the pattern in a vertical way, like we are keeping the book in the shelf. Okay, this is the one method. And you then vertical stacking can be done. how long, how to the height that the specific designers are available to design the pattern, design the rack to keep the pattern. And second, while lifting the pattern with the crane, you should have a proper arrangement for the threading, drilling, tapping, threading. The hooks can be provided to the pattern to lift the match plate along with the pattern. These are the different ways to handle the pattern and keep into the rack.
I think he is satisfied with that. I hope. I think it depends on how you are keeping the pattern is depend on that how you can handle the pattern, isn't it, Deepak?
Yes,
The
yes,
first thing is that is important, but I think storage of pattern is very important, and you have to be because basically it is not your property; it's a customer property. You have to mind it that you are handling customer property.
yes,
So any damage to that will be directly impact on you. So you have to be careful on that. So next question here is during the checkpoints. This is for Prasad, I think. During the checkpoints, you highlighted a point regarding charge mix with 75% yield. How can we plan 30 to 40% RR? What is this situation for this? So I think Prasad is asking, Prasad, I think he want to understand if there is a yield 75% means 25% RR generation is there.
Yes, definitely.
So if somebody is asking you to use 30 to 40% of RR, how you can be generating those additional, we can say 5 to 15% of RR. Maybe I think rejection you are talking about or something.
No, it is about a charge mix sheet. So that I have given a simple charge mix calculation sheet solution. If we don't have RR, we have to arrange a 500 kgs of a melt. Definitely, it is our target. So what to increase and at what amount to increase? A supervisor don't have that much of a time to think that do this, do that. If he has this kind of a sheet at a shop floor on his mobile phone, he can definitely check all the possibilities and do likewise, so that with the optimum material consumption we get the targeted results.
Anything? I think the answer is adequate. I think the one thing is even though 75% deal means 25% RR is already generated, and
Yes,
there may be another. So a person can use around 30 to 32% of scrap as it is itself. And you rightly say maybe it happens that sometime you have to use some more CRCA because that particular grade are not available, and in other time you have to you can increase RR when it is available,
yes.
reducing the CRCA.
But at addition of a CRCA, extreme addition of a CRCA, what should be the other alloys addition? That must be known.
Yes, definitely. So charge if the importance of charge calculation is there always.
Yes,
Before you start the production, you should have your fixed charge, and whatever alloy addition will be there. I think you should have that calculation with you, and you should validate that whether your calculation and actual additions are matching or not.
yes. The deviation should be calculated.
Yes, absolutely. I think there is Varadraj is asking a question.
Hello,
Yes,
Sandeep
sir.
ji.
Yes, sir. Yes,
And
sir. Good
and
evening.
Mr.
Welcome.
Yeah, good evening, good evening. Yeah, because I specifically raised that question because actually in a foundry normally this problem arises. Actually, there will be a shortage of this returns many times. So
Yes,
sometimes actually the melting people demand for this say cast and scrap in particular. You know, it may not be available every time. That's why very purposefully I raised this question actually.
yes.
Yeah, sir. Can I interfere in between?
Yeah, please.
Yeah, I think this is a very sensible question and a very important question, and I have gone through these particular situations many times, and I could explain like that. many times what happen, we give certain charge mix to the supervisor and they are trying to follow it. But unfortunately, what happens, a day on which we have a ferritic grade planning, we do not have ferritic grade RR available because those are not short blasted or term blasted, or those are not lifted from your knockout area, and at melting date they have 500 bar 7 RR available. So many times I have seen people are not aware that it is 500 bar 7. They're trying to use those RR for the melting. And what happens? Manganese increases, you will have much stability issues, your hardness goes increasing. So it is always better to check whether the RR of available grades which is running is available or not. It is always wise thinking I am doing, or I suggest to the my shop floor or anybody that in ferritic grade you try to increase CRCA, because in most of the cases we find that in CRCA we are very difficult to get low manganese CRCA. Most of the time the CRCA containing manganese around 2.25, 0.3, 0.4 even. So it is very difficult to maintain manganese in ferritic grade with more CRCA. So whenever availability is there of low CRCA, you increase the percentage of CRCA and utilize your RR for 500 bar 7 grade, so that you can combine the effect. So commercially you get benefit, because if you use the 500 bar 7 RR for the ferritic grade, your quality will go for toss, and also commercially you will be going for the loss because your copper manganese will be going in an unnecessary way.
Sandeep ji, can I ask?
Yes, sir.
Yeah, sir. Actually, you are more specific on this SGN issues, but I think in SGN this problem may not come actually, because mostly the yield will be something around 65-75%. That's what my feeling
Yes.
actually.
Yes.
So maybe sufficient returns may be available actually, mostly in the case of SGN. This problem can happen in my experience in the case of gray and castings. So where we get 75 to 80% yield, and when we go for this type of charge mix with 35 or 40% returns, there comes the question actually. Then my one more clarification, what I request from Mr. Prasad actually, suppose instead of this RR, when we go for the other ferroalloy addition, that may be the addition you are highlighting. So when we go for the alloys addition,
Cast iron.
how
You
economic
have a
it
number
will
of
be?
varieties. Actually, in cast iron is of material available.
Yes, sir. We just take the case of FG260 grade.
Okay.
Okay. So instead of this RR, you are
Hmm.
suggesting with this calculation, we should particularly concentrate some particular element.
Hmm.
Okay.
Hmm.
Then go for the compensation. That's a
Hmm.
proposal, no?
No, that is not actually proposal. If
Ah,
we don't have RR, we can't
ah,
use, because it
okay.
is not available. We can't use.
Okay.
But our target is to make a 500 kgs of a pot. Definitely, we have to pour a certain amount of a metal to pour.
Exactly. Definitely. Yeah.
Exactly.
Yeah.
So we have to pour something else rather than RR. It is clear?
Definitely. That's true. That's what
Definitely.
it is. Yeah.
So when we add these all kind of material,
Ah,
definitely our stated charge calculation get deteriorated. So the
okay.
alloy additions goes on different for different type of a charge mix.
Okay. Absolutely.
But ultimately we have to control the target chemistry. That
That's the
is the
ultimate
hurdle
aim.
at a shop floor.
Yeah.
So how we can approach for that hurdle
Ah,
to give a charge mix calculation sheet
yeah.
like this, or any kind of a customized at your plant. At Sandeep sir has also developed his own charge mix calculation. He has also put on a DFG group,
Yeah.
so that the people can get a solution within few minutes
Mm.
at
That's,
their activity.
yeah.
That is the approach.
Okay. This is this solution may be on a crisis situation. That I agree.
Yes.
Here,
suppose,
Varadaj sir, here I would like to add one more thing to Prasad's comment.
yeah,
Even though he can deteriorate, he cannot deteriorate in two of the materials, that is pig iron and MS scrap. He cannot change the percentage given for pig iron and MS scrap. He can deteriorate in RR, he can deteriorate in cast iron scrap, he can deteriorate in boring.
Yes,
Because
yes.
if you have 260 grade or if you have 300 grade and the requirement of the grade is MS 35% or 40%, the scrap is not available, so he pour the material with just 25% MS, you will not got the desired properties.
yeah,
So you
Definitely.
can't change the pig iron and MS scrap.
mm,
It
Yes, yes,
has to be constant. Other thing he can play with based on the
yes, yes.
availability, and he can adjust the alloy addition based on the calculation.
agreed. Sir, actually, no, I agree. I truly agree to that point. My one clarification, what I'm requesting with you, experienced people, what I'm requesting you. Suppose because in a foundry, when we are continuously producing grain, maybe we know the yield will be 75% or 85%. Take it as
Correct.
75%. Okay. So we will be generating only 25% of RR.
Very true.
Maybe 25% this return plus maybe another 5% rejection. That will be 30%. Okay.
Correct.
We put it on the safer side. But our charge mix demands for 40% RR. Then on a regular basis, what is the best method to control or find out that 10% or 5% RR? Whether we should permanently procure this returns or cast and scrap or alloy addition, which you prefer? That's the point I want to take a clarification from.
Prasad, can you give, or I will cover?
No, sir, you can better do
Okay.
answer.
Okay. So your question is very relevant one. If you have that 10 or 15% gap, and I think every foundry in which is making cast iron have that the same problem is there, that they have gap of 10 or 15%. Either you have to add turning boring, or you have to go for cast iron scrap, automobile scrap, or machinery scrap available in the market. It depends on the commercial factor. It depends on what kind of casting you are producing, whether the incoming scrap is suiting to your casting, it is not deteriorating your quality of casting. All those things you have to consider. Turning boring is one of the better option, I feel. If you have a 10 or 15% gap, it is always better to go for turning boring of good quality, so that you can reduce your cost of scrap or your melting
Okay.
scrap,
Okay.
and you will also get good result in terms of you can say power consumption and cost wise both.
Okay. Okay.
Because again, purchasing the CI scrap is a little risky work, because
Correct.
you must, there will not be uniform kind of material availability is there. There
Yeah.
may be different types of material available, so
Yeah.
charge mix and calculations, there may be chances that some gunmetal or aluminum can go inside the furnace because of that. So all these risks are there. If you have a reliable supplier for cast and scrap, you can go.
Yeah.
Otherwise, it's better to go for turning boring.
Okay. Okay. Noted. Thank you.
Any more questions? Anything on the chat box? I'll just verify it. I think no. I think both have given their numbers. You can contact them for even Excel sheet or whatever information you want. They will definitely help you in that regards. So thank you, Prasad, and thank you, Deepak, for your excellent presentation and good inputs to all of us for daily foundry management. It's a long topic, and I think the way your approach towards this presentation was there, I was really happy that the concept of mind behind this topic was 100% fulfilled, or you have given a right justice to that concept, I think. So thank you very much for your nice presentation and your time. And all the participants, thank you very much for spending your valuable time, especially when IPL is going on. The way you have come out and spend your time, thank you very much. definitely will going for better topics in the future as well. The next topic is very interesting topic again. It's not a technical topic. It's a topic of QMS. What Prasad has left, where the Prasad has left, we'll starting from that angle in the next topic, that is importance of QMS, that is ISO 9001 2015 in the Foundry. So we are all looking at ISO or QMS, but what and how you can utilize that QMS or ISO in the Foundry effectively to earn the profit, or to earn or the or we can say overcome these problems and increase the efficiency. Those points we are going to see in our next webinar. The details I will share in the next couple of days. Mr. Sridhar will be there with us for that webinar. So kindly join. I think it is next day to Dasra. That is on Monday, 26th. I hope 26th of October we'll be having that webinar. So kindly join us for that webinar as well. So thank you very much. Stay at safely and very we can say healthy, safe and healthy life. Thank you very much for joining here again, and good night, everyone. Thank you, Deepak and Prasad, once again.
Yeah, thank you, Sandeep. Thank you, everybody. Have a nice.
Thank you, sir.